Okay, so what we're going to do is I'm going to give you guys a formula, and you're going to break it up into its ions. Remember the rules. There's always two ions that you need to break it up. It's kind of easy when those two the whole formula is just two elements, because the first element gets broken up, and those two elements get broken up into individual ions. But when there's more than two elements, that's when it gets a little tricky. It's not too bad if you just kind of follow a few rules. All right, so let's go ahead and try this. All right, so let's say you have this substance here, KF aqueous. What does KF aqueous look like? Once again, aqueous means that it's dissolved in water and that they're broken up into their individual ions. Okay. So, how many elements here in this formula? Two, right? Two elements, we need two ions. That means each element's got to be an ion. So we basically break it up right here in the middle. All right, so we're going to break it up into K and F. But remember they're ions, so we need to make sure that we go ahead and get a charge on each one of them. Potassium is in column 1 of the periodic table. Because it's in column 1, it gets a +1 charge. You recall that from chapter 8. And fluorine's in column 17. Everything in column 17 gets a -1 charge when it forms an ion also, right? Okay. Quick reminder, since it's been since December that we learned this, on the periodic table, especially on the right side, all the noble gases, they don't form ions, they get a 0 charge. And then we just get more negative as we move left, column by column. So column 18, a 0 charge. Column 17, -1. Column 16, -2. Column 15, -3. Okay. And so there are our charges right here on these guys. Okay. You could, to finish up, go ahead and put these both as aqueous because they're floating around in water. It's basically what aqueous means. Floating around in between the water molecules. Okay. And there you go. Pretty easy, right? So yes, tomorrow if you have a problem that says KF aqueous, you just know it breaks up into potassium ions and fluoride ions. Then we might be doing something with these individual ions later on, like canceling them out or doing something else with them. All right, that's example number 1 of 8. Different things happen with different, so that we got 8 of them to go. Let's do the second one. Li2S aqueous. What does that look like? What does that break up into? Once again, how many elements? 2, just 2. Lithium and sulfur. So that's not too hard to break up into, right? Just break it up into lithium and sulfur. But remember, they're lithium ions and sulfur ions. So they need to have charges. Lithium is in column 1, like potassium, so it gets a +1. Sulfur is in column 16, like oxygen is, so it gets a -2. Okay. Now you'll notice that our formula here has a 2 as a subscript. Right. The reason for the 2 as a subscript? To cancel, to balance out the charges, right? To cancel out the 2 negatives on the sulfur. You needed 2 +1s. So because this 2 was there just to show that we need twice as many lithiums as sulfur, what you do is bring it out in front. So when you break it up, the 2 subscript now goes in front of the lithium ion. This implies that both these lithium ions are on their own, as opposed to being attached together. Okay. And there you go. You can also put them as aqueous. It's not required that you put them as aqueous down here. And I'm sure I'll stop doing it in a little bit, but they are aqueous. Ions by themselves, like this separately, cannot exist in the solid state, because the solid state implies that they're all together and compacted. And since these are all negatives, they don't want to be compacted together. They'll be solids when they're together, right? In the solid state, like here with this. I got sodium and chloride in here. I got positive ions and negative ions in here. So they can stand each other because they're balancing each other. But this thing by itself wouldn't be in a solid state, nor would this one, because they're all the same charge. Any questions so far on these? These were the easy ones because they're made up of two elements. Although, I guess they don't get that much harder. All right, the third one, NiCl3. How many elements? 2, right? Okay. So there's 2 elements, same idea. Let's break it up into those 2 elements, break them into the ions. There'll be an ion of nickel and an ion of chlorine. All right, so let's figure out what the charges are. Once again, they're ions, therefore they will have charges. Do we know the charge on nickel? What was that? +3? Oh, good. How did you get +3? Okay, good. So you're looking at chlorine. Yeah, nickel, remember, is a transition metal. So there's no rule in the transition metals set. You have to kind of figure it out. So the formula is 1 nickel and 3 chlorides. Right? Chlorine is in column 17, so it's a -1 charge. There were 3 of them. I can put this 3 right here as a coefficient here to show that we're going to end up with 3 chlorides individually. Right? So there's 3 negative charges for a total of 3 negative charges. That must mean that there's 3 positive charges, and there's only 1 nickel to take those 3 positive charges. So that nickel is a +3. So we call that one. We call this one nickel 3 chloride. So when there's a transition metal, remember you got to kind of figure out what the charge is going to be. Okay. That's the difference between. See, the first one was just straight 2 elements, but straight 1-to-1 1-to-1 proportion, 1-to-1 ratio. The second one, there was kind of a 2-to-1 ratio, but we knew the charges. The third one is also a different proportion between the 2 ions, but one of them is a transition metal, so you have to figure that out. Good job. All right. Any questions on this one? Well, we broke it up where we broke it up. All right, let's get to some more fun stuff. All right. K2CO3, aqueous. When it's K2CO3, what are the ions? Let me move this up a little bit here. How many elements in this one? Elements? 3, right? There's potassium, there's carbon, and there's oxygen. But there's only 2 ions, so where do we break this apart? Here's the little rule. Usually the cation, the positive ion, is made up of 1 metal. So the first element is usually your cation. Usually. The exception is when ammonium, the only positive polyatomic ion that we're using. When ammonium is your cation, then it begins with ammonium. But if not, it's just usually the first element is your cation. And then the rest is the anion. Another thing you could have done here is, since you went ahead and you studied for that quiz, and you know that CO3 looked familiar, you go, oh wait, hey, that's carbonate. So here we can go, the cation is potassium, and the anion is carbonate. Because once again, we've got that memorized. We recognize it, like, oh, that's carbonate. And not only do I remember that carbonate CO3, but it has a -2 charge. Because remember, these polyatomic ions, we don't look on the periodic table, you just have to know them. So, okay, there's carbonate here. It's got a -2 charge. Potassium is in column 1, it's got a +1 charge. There we go. Since the 2 is not part of the formula for potassium, we bring it up to the front. But the 3 doesn't get moved up to the front, because the 3 is part of the carbonate formula. Okay, we have to keep the carbonate together. It's telling us that the carbonate has 1 carbon attached to 3 oxygens. That's your carbonate ion. If we had moved the 3 to the front, it's going to tell us a different thing. It's going to tell us that we have 3 COs, which is like having a CO, then a CO, then a CO. That's what that implies. Okay. So when the subscript is part of the polyatomic ions formula, you don't move it to the front. But when it is just there to show you how many of that ion you needed, then you do move it to the front. Any questions on number 4? This is basically what you're going to be doing on your homework. Let's do some more, just so you can see. Let's do this one, Cu3 PO4 aqueous. One more, another one with 3 elements. I'm going to break this thing up. Once again, always into 2 ions. The first element is your copper, so you break it up after that. And you'll notice that after the orange line right there is PO4. Look familiar? Yeah? From the quiz? Phosphate, right? So we're going to have copper ion, some type of copper ion, and the phosphate. Once again, because we memorized the polyatomic ions, we already know not only is phosphate's formula PO4, we already know that the PO4 is phosphate, but we also know it has a -3 charge. And since this is -3, and there are 3 coppers, it means each copper has to have a +1 charge, right? Because there are 3 coppers. We move the 3 in front of the copper. Usually the subscript of the metal goes to the front. All right. Notice kind of the same thing between these two, except this one we had to do like we did with the nickel. We had to figure out what the charge was. Copper can come as +1 or +2, and if this was copper 2, we would have needed 2 phosphates. I have to put parentheses around the PO4. But since we only had 1 phosphate, that means we only had 3 negatives in this formula, so we had to have 3 positives. Okay. All right. 5 down, 3 to go. Let's do another one. They're getting a little more complicated. Well, sort of. I actually think that might be the most complicated one, and I'll show you why in this next one. So here we have SnClO3 2 aqueous. What are the ions that we break this one up into? Oh, this one kind of has a giveaway. See those parentheses? Remember the parentheses, why we use parentheses? We use parentheses when we need more than one of a polyatomic ion. So it's kind of the giveaway that this inside the parentheses is our polyatomic ion. Whenever you have parentheses, whatever's inside the parentheses is your polyatomic ion. And following the other rule, the first element is a metal, and we separate that out. So both ways we can figure out that we're going to have a tin, Sn is tin, a tin ion, and the ClO3 ion. Tin ion and ClO3. Anybody remember what ClO3 is called? What's this element? Huh? Chlorate, right? Chlorate has 3 oxygens, and it has a -1 charge. Okay. Once again, just from the quiz. So, turns out, see the 2 out here? Turns out we needed 2 chlorites to make this thing balance out. So now we're going to take this 2, not the 3. The 3 is part of the polyatomic ion, but the 2 on the outside, we're going to use that as our coefficient. All right, so the only time we get coefficients of polyatomic ions are when we have parentheses and we use the number on the outside of the polyatomic ion. Once again, this implies that there's 2 chlorites and they're separate from each other. Okay? So what does the charge have to be on tin? Tin has 2 options, tin 2 and tin 4. But even if you didn't know those options, can you figure out what the charge is on tin? +2. Correct. Yeah, because there's 2 negative ones for a total of 2 negatives, right? So the tin has to have 2 positives, so it's a +2. Those are ions. Okay. So see how, I don't know about you guys. I think this one was easier than the previous one because of the parentheses. Here's another one kind of like that, just to show that it can be a little different but the same. NH4 2SO3. All right. Whoa, how many elements in this thing? 4 different elements. Where do we break up the ions here? Well, once again, it's a giveaway, right? We got parentheses. This time we got parentheses at the beginning of the formula. Why? Because our polyatomic ion now is our ammonium ion. The one exception to our cation being a metal. So one of our polyatomic ions, NH4, we know NH4 has 1 positive charge because we memorized it for the quiz. And since there's a 2 in front, outside of the parentheses, we bring that to the front. That releases the 2 ammoniums to all go their separate ways. And the other part is our SO3, which we remember is called what? Not sulfate.
Sulfite.
Sulfite, yes. And sulfite has a -2 charge to it. Okay. So see how we're doing it? In all these cases, we're breaking them up into 2 ions. 2 ions. It's always 2 ions. When there's 3 or more elements, one of those ions has to be a polyatomic ion. Okay. So once again, that's why you have to. I don't know if you really have to memorize polyatomic ions, but if I don't quiz people and get them to look at them for a little bit, then even if you have the list in front of you, people have a list in front of them of the polyatomic ions, and they still can't recognize them. All right, let's do one more. Let's get rid of these giveaway parentheses and see if we can figure this one out. NH4 ClO2 aqueous. Another one with 4 elements, but there's no giveaway here. 4 elements, how are we going to break this up? You recognize anything in that formula? NH4, right? NH4 is ammonium, just like we had in the previous one. So we can break that up. Your cation will always either be a metal or NH4. Those are the only options. So you'll either see some type of metal in front here that you'll separate from the rest of it, or NH4. So this breaks up into NH4 with 1 plus charge, because it always has 1 plus charge, and ClO2, chlorite, with 1 negative charge. And there you go. Notice why we didn't use parentheses on this one. Because there was 1 positive and 1 negative, so we only needed 1 of each. When you only need 1 ammonia, you don't use a parentheses. When you only need 1 chlorite, you don't use parentheses. Now, one last thing to point out. First off, any questions on any of these? How I decided to break them up? Where I got the charges? Why I moved the coefficient to the front? I'm sorry, the subscript to the front as a coefficient, and why I didn't move some of the subscripts. Okay. Know all those things. Like I said, in tomorrow's 4-step procedure, this is just step 2 of it. But I think it's the kind of hardest step. The other steps are just like looking on both sides of the equation and canceling stuff that appears on both sides. One thing to note, since I've done so many examples of these guys here with 4 elements, when an ionic compound is made up of 4 elements, it doesn't always necessarily break up in the middle. Sometimes you'll have something going on like this. You'll recall that acetate is an ion that is made up of 3 elements. So if you have KC2H3O2, you don't break it up in the middle. But the first element is potassium, which is a metal. So once again, your metal is usually separated from the rest. And so this one, for example, here, you're going to break up between the potassium and the rest. And the rest here is the acetate ion. Okay, so don't just automatically assume 4 elements, 2 in my cation, 2 in my anion. You have to recognize the polyatomic ions. Or if you didn't recognize the polyatomic ion, this one, recognize that your first element is a metal, and the metal gets separated from the rest. Okay? All right. So stop there on that one.